Hello all of you, I am Miss Amruta Jadhav ma'am, your physics teacher. So as you all know that we have finished chapter electrostatics with all its theoretical part. So I hope you have seen all the videos which gives you idea about theory of electrostatics. And in that theory we have derived so many derivations and so many formulas which we are going to use to solve numericals. So here and onwards we are going to discuss the numerical part of electrostatics. So I am here with the part 12 in which we are going to deal with numericals. So let's not waste time and let's move towards the numerical part. So here is the first numerical, which is a sphere of radius 10 centimeter carries a charge of 1 microcoulomb. Calculate the electric field at a distance of 30 centimeter from the center of sphere, at the surface of sphere, and at a distance of 5 centimeter from the center of the sphere. So here is the numerical. So we are going to see what exactly given in this and what formula we are going to use for this. So as it is given over here, sphere which is conducting and radius and charge is given in this. So we are going to consider a charge which is conducting sphere. We are going to consider a sphere which is conducting, having radius 10 centimeter, charge 1 microcoulomb. So let's write down the given things here. So here is the first given thing, Q 1 microcoulomb. So as it is microcoulomb, we have to convert it into coulomb. So to convert it into coulomb, we have to multiply it by 10 to the power minus 6. So we are having Q as 1 into 10 to the power minus 6 coulomb. And even R is given as 10 centimeter. Okay. So electric field intensity we are going to find out at a distance of 30 centimeter from the center. So here is the formula, which is E is equal to Q upon 1 by 4 pi epsilon 0 R square. Now the distance is given, which is 30 centimeter. So we are going to write it as R is equal to 30 centimeter. By converting into meter, we are getting that as 0.3 meter. By substituting all the values inside formula, we will get 9 into 10 to the power 9 is the value for 1 by 4 pi epsilon 0. Okay, so 9 into 10 raised to 9 into Q is what? It is 1 into 10 to the power minus 6 divided by 0.3 bracket square. If you solve, you will get 0.3 square is nothing but 0.09. Here is 9 and even in denominator it's 9. So by it will get cut and we are getting only power of 10 as the answer. So the answer is 10 to the power 5 Newton per coulomb. So this is the answer for electric field intensity, which is at a distance of 30 centimeter from the center of sphere. So here is the answer for first one. Now what will be the answer for second, which is at the surface of sphere? What will be the intensity when the particle is at the surface of sphere? Suppose we consider this is conducting sphere and we are going to find intensity at this surface. So what will be distance between them? It will be the radius. So as the radius is given as 10 centimeter, we will be considering r as 10 centimeter. By converting it into meter, we are getting this. In the similar formula, we are going to put all the values here. We are getting value as 9 into 10 raised to 5 Newton per coulomb. Now, E at a distance of 5 centimeter from the center. So, what is given in this? Distance of 5 centimeter from the center. What is radius of the sphere? It is, I will draw it again. Sphere which is conducting. Radius of this sphere is 10 centimeter. Right? This is conducting. And we are going to find out the electric field intensity, which is at a distance 5. That means maybe here. If it is at a distance 5 from the center, so it will be inside the sphere. Am I right? If the radius is 10 itself, then from the center 5 centimeter will be inside a sphere. So what is the electric field intensity inside the sphere? It should be 0. So E at a point 5 centimeter away from the center is E is equal to 0, as intensity inside a body, inside a conducting body, is always 0. So here is the first solution for the first one. Okay, so let's move towards the second one. So here is the second one. The length of straight thin wire is 2 meter. It is uniformly charged with a positive charge of 3 microcoulomb. We'll draw a diagram. A straight thin wire is there who's having length 2 meter. Okay, it is uniformly charged. Uniform charge is there, and charge is 3 microcoulomb. We have to convert it into coulomb. Alright, we'll do that. What we are going to find out? Calculate the charge density of the wire. What is charge density? It should be a linear charge density, as it is a wire. It is linearly distributed. So lambda will be charge divided by length. So as we know, what is charge? Charge is given as 3 microcoulomb. Length is given as 2 meter. So we can find value for charge density, which is lambda. It is as easy as that. Second, the electric intensity due to the wire at a point 5 meter away from the center of wire. Now I will draw the diagram again for you. This is the wire. If the length is 2 meter, here it will be a center O. Now electric field intensity due to wire at a point 1.5 meter away. It may be over here. It may be 1.5 meter away. Here I wanted to find the electric field intensity. Am I right? So electric field intensity is given as, in terms of lambda, it is lambda by 2 pi epsilon 0 into R. Okay, so as I know, or as we all know, the value for 1 by 4 pi epsilon 0, I have converted that formula into this form. I just multiplied numerator as well as denominator by 2. So I am getting here as 2 lambda and here as 4 pi epsilon 0. So value for 4 pi epsilon 0 is nothing but 9 into 10 raised to 9. Okay, what is 2? Will be as it is. What is lambda? We have calculated that by putting that divided by R. R is nothing but 1.5 meter they have given us. So we are getting value as 18 into 10 to the power 3 Newton per coulomb. So the main thing when you're solving a problem is you have to convert all the given things in a single system of units. This is the first important thing. And second important thing is you have to write down formula in proper format. Third thing, when you're writing answer, unit is compulsory. Then and only then you will get full mark. Okay. So these are the things which is very important while you are solving a numerical. Let's move towards the next one, and here it is. It depends on the potential and even the work done. Okay, let's find it out what it is. A potential at point A in space is given as 4 into 10 to the power 5 volt. So V is given. Potential at point A in space is given as 4 into 10 to the power 5 volt. Find the work done in bringing a charge of 3 microcoulomb from infinity to the point A. Okay. So as we are bringing a charge of 3 microcoulomb from infinity to a point A, some work has to be done, and that work we are going to find out. That is the first part of this numerical. Let's see what is the second part. Second part is, does the answer depend on path along which charge is brought? Does it depend on path? Not at all. It doesn't depend on the path. So it is independent of path. You can write the answer over here. No, the work done is independent of path. So the first that we are going to find out is find the work done in bringing charge. So formula for work done is V infinity is Q0V. As V is given, even Q is given, you can directly put the values over here. It's very easy. One step forward answer is there. So you are getting W infinity as 1.2 joule. It is very easy. It can be asked for only 1 mark. So such kind of numericals can also be asked in MCQ and even for the VSA type. Only you are going to put the values in that formula, which is QV. It's as simple as that. Okay, so here is this numerical. Second one, fourth one, we are going to find out. Even this, if 120 joule of work is done in carrying a charge of 6 coulomb, a charge is there whose value is 6 coulomb, and we are going to carry the charge, and to carry that charge to some place 120 joule of work has to be done. So what is given over here? Given things are W. How much amount of work is done? 120 joule of work is done. What is Q? Q is nothing but 6 coulomb. No need to convert. Then a place where potential V is 10 volt and another potential where it has to move, that we are going to find out. I will explain this example. I think you all didn't got this one. Okay, so this is charge Q0, which is having value 6 coulomb. All right, so this Q is at the potential. This is having potential 10 volt. Okay, now if this is at point A, this is situated at point A, I want to bring that charge to another point, which is B. I wanted to move this Q0 from A towards B. At A, V is 10 volt. At B, V may be something that we are going to find out. But to move this charge from A to B, work done is done. That work done is given as 120 joule. Now, what we are going to find out, what is this place, that means point B, at what potential it is situated, so that work done is nothing but 120. So what are the given things? VA, potential at point A is 10 volt. Potential at B that we don't know, we are going to find out, which is V. WAB is given as 120. Q0 is 6 coulomb. So what is work done, or what is potential difference? It is nothing but difference between potentials, and that is given as work done divided by charge. So VB minus VA is equal to WAB divided by Q0. This will be the formula. So as we don't know the value for VB, we are going to write this as only V. So here I am writing as V. What is VA over here? VA is 10. WAB is 120. Q0 is 6. So you are getting V minus 10 as 20. So what will be V over here? It will be 30 volt. So what you are getting, when a charge of 6 coulomb, this is Q, 6 coulomb, is situated at point A, which is having potential 10 volt, when it is moved to point B, which is having potential 30 volt, then to move this, you will be having work done of 120 joule. So that is what we have find out. Okay. So let's move towards the next one. A parallel plate capacitor has an area of 4 centimeters square. Now this is depends on capacitor. This is parallel plate capacitor. One of the plate is having positive charge, another plate is having negative charge. It must be grounded over here. This is the capacitor. This is having area. The parallel plate is having area. So the parallel plate capacitor is in front of you. A plate is having area 4 centimeters square. So this plate and this plate is having area 4 centimeters square. Distance between both of them means this is 2 millimeter, that is given. Now we are going to find out its capacitance. So let's write the given things first. A is 4 centimeters square. So by converting it into meters square, we are getting 4 into 10 to the power minus 4. Here it is. D, which is 2 millimeter. By converting it into meter, we are getting 2 into 10 to the power minus 3. Epsilon naught, which is 8.85 into 10 raised to minus 12 coulomb per Newton meter square. This is the constant term which is given actually. So now we are going to find out capacitance. So which formula we are going to apply? As a parallel plate capacitor is mentioned over here, so we are going to take the formula for parallel plate capacitor, which is not having any dielectric within its plates. So the first one, which is C is equal to A epsilon naught divided by D. This is the formula in which two parallel plates are away from each other and there is a air as a medium, not any dielectric slab in between them. Alright. So by using this, we are going to put all the values inside it, and by solving it, we are getting the value as 1.77. It is very easy. You can calculate over here. 2 2s are 4. So you have to only multiply this. 2 into 8.85. So that is nothing but 1.77 and into the powers of 10. Okay. So here it will be 10 to the minus 4 and 10 to the minus 12 will be 10 to the power minus 16. and this will be plus 3. What will be that? Minus 13. By rearranging, we are getting it as 1.77 into 10 to the power minus 12 farad. As I told you, if you're writing answer, you have to write down the unit as well. Then only you will be getting marks for it. Okay. So here is another one. So let's see what it is. The dipole moment of water molecule is 6.3 into 10 to the power minus 30 coulomb. A sample of water contains 10 to the power 21 molecules whose dipole moments are all oriented in an electric field of strength 2.5 into 10 to the power 5 Newton per coulomb. Calculate the work to be done to rotate the dipoles from their initial orientation theta 1 is equal to 0 to 1 in which all the dipoles are perpendicular to the field, that is theta 2 is equal to 90 degree. Okay, I have just read all the numerical. Now I will explain what exactly it is. Okay, so this example is example of water molecule. Okay, so as water molecule is given, so the molecules are oriented inside a material, inside any space where they are. So dipole moment of this water molecule is given. Okay, and a sample of water contains 10 to the power 21 molecules. There is not only one molecule is there, there are 10 to the power 21 molecules. So whatever answer you are getting, that has to be multiplied by 10 to the power 21, because we have to find out it for all the molecules. Okay, so the electric field of strength is given as 2.5 into 10 to the power 5. Okay, if you have question like what is dipole moment and why it is for water molecule, what is the formula for water molecule or for water? H2O is the formula, right? So the molecules are separated, H and O are separated from each other. When they got separated from each other, they will create a dipole moment. Am I right? So as they create dipole moment, it is having value of 6.3 into 10 to the power minus 30. Okay, so as we are giving electric field to this molecule, what will happen? All these molecules are try to orient inside the field. So their orientation is from 0 to 90. So we can take theta 1, that is initial orientation, as 0 and the final orientation as 90 degree. Alright, so we'll write the given things. What is given? Dipole moment. Just write down the dipole moment. Here it is. N, number of molecules. How many number of molecules are there? 10 to the power 21. Written. What is electric field given to that? It is 2.5 into 10 to the power 5. Written. All given things are written over here. Now, as there are 10 to the power 21 molecules, I have written the dipole moment in that sense. So I have multiplied 10 to the power 21 to this answer. So I am getting dipole moment in this sense. 6.3 into 10 to the power 9. Okay. So let us find out the work done. Work done is nothing but PE into bracket cos theta 1 minus cos theta 2. By putting all the values which is given, P, E, theta 1 and theta 2. What is cos of 0? It is 1. Cos 90, it is 0. So the bracket will give you the value as 1 only. Here you are getting only 1 as a value. So by calculating this 6.3 into 2.5 only, we are getting this value as 1.575 into 10 to the power 15 joule. So this is the answer for work done. This work done is required to rotate the water molecule by the angle of 0 to 90. 1.575 into 10 to the power plus 15, it is very high. That kind of work done has to be done to move the water molecule. Okay, so these are some examples which we have solved. We are going to solve some more examples, and if you have any query regarding this, do ask me. I will try to solve your query. Okay, thank you so much.